Welcome to your video of the volume of cross-sections. Hopefully you have tried these on your own, checked with other people and seen what you can come up with. But if not, here you go. I'll give you some work on this one. Alright, some solid has a circular base of a radius of 3. Notice no equation is given to you, because at this point in the game we kind of expect that you should be able to write the equation of a basic circle. So we can assume that this is just x squared plus y squared equals 9, because again the formula for their circle is x squared plus y squared equals r squared. So I need to draw that picture. There it is. We've got 3, negative 3. Should be good enough. If every plane cross-section perpendicular to the x-axis, kind of important, because when we actually are placing these, imagine putting these on the Play-Doh, you're putting them going this direction. So we're perpendicular to the x-axis, which means we're integrating with respect to x. Again, another good thing. Is an equilateral triangle. So imagine we're just going to stack a whole bunch of triangles on here, very similar to the notes that you took yesterday. So we definitely need to know the area formula for the equilateral triangle. Square root of 3 over 4, side squared, base squared, what have you. And we want to find its volume. Well, if I'm going to integrate with respect to x, I definitely need an equation in terms of x. So I'm going to take this equation and I'm going to solve it for y. So I get y squared equals 9 minus x squared. Remember, when we take the square root, we get that plus or minus square root of 9 minus x squared. Important to note that, because then we know that the positive half of this function represents the square root of 9 minus x squared. But the bottom half of this function is negative square root of 9 minus x squared. And you can verify that fact if you put these two equations into your graphing calculator. Now, my volume function, since I'm integrating with respect to x, means I'm going from my left to my right. So my limits would be negative 3 to 3. And I know the square root of 3 over 4 is part of this, because it's the accumulation of my areas. So I need my area formula. But what I need is what's going to go in here as my side squared. Your length of your side of your equilateral triangle is controlled by these functions. So it is smaller over here toward the edge of the circle, largest as it goes right through the diameter of the circle. And what causes that length of that diameter or radius or what have you to change is these two curves. So just like when we found the area between two curves, it's the same idea. This top curve and bottom curve are controlling your side. So my side length of my equilateral triangle is going to be my top curve minus my bottom curve. And when that is all nice and simplified, that means the side of every equilateral triangle is 2 times 9 minus x squared, and the square root of that. So if that's my side, awesome. I'm going to put that right in here. And essentially, that should be the tough part of this problem. The rest of this, hopefully, is actually pretty straightforward. Square root of 3 over 4 is just a constant, so we can bring it out in front of the integral sign, if that makes us happy. We want to simplify before we integrate. So therefore we square this, we get 4, 9 minus x squared dx. That 4 can also come out as a constant. Well, isn't that kind of convenient? Those 4's will cross out. Square root of 3, 9 minus x squared dx. Let Math 9 take it from here. A little practice, though, with integration never hurts, so we should be able to do our antiderivative, which would be the square root of 3, 9x minus x cubed over 3 from negative 3 to 3. So again, notice when I do my antiderivative, the integral sign is gone from there. And again, you can substitute the information in. You can use Math 9. Regardless, you should get, if you use your calculator, 60.2.354. If you do it using a fundamental theorem of calculus in terms of the square root, it's also 36 square roots of 3. All right.